All right, hello everybody. This is Mr. Fleming coming to you with another lesson about rational functions. So in the past couple of weeks, you've been learning a lot about asymptotes and graphing rational functions, and today we're going to learn about how to solve some of them. It's kind of cool. So just a reminder that rational, you're just thinking of a fraction. You're going to have a numerator and a denominator. So if we look at this first question, 4 over 3 equals 5 over x minus 1, you probably see, oh, there's a fraction on both sides. That means I can cross multiply. And you'd be right, because you can just multiply x minus 1 on both sides, and you can multiply a 3 on both sides. So just a note, whenever you're cross multiplying, keep any binomials like this one together as a pair with some parentheses. So when you cross multiply, you're going to get 4 times x minus 1 equals 5 times 3. Perfect. So then this is just, some algebra 1 with some distribution. 4x minus 4 equals 15. Add 4 on both sides. You're left with 4x equals 19. X equals 19 over 4. Not too bad, right? So as long as you're, cross multiplying, you're in good shape. So we're going to amp up the difficulty a little bit and go with a little bit more variables. So here we have a fraction on both sides, so we can go ahead and cross multiply, just keeping those binomials together. So if I just do this, we're going to left with x times x plus 2 equals negative 8 times x minus 3. All right, this one's going to be a little different because you notice we're going to have a quadratic. So you're going to get x squared plus 2x equals negative 8x plus 24. So you notice we're going to have to move all of this to the other side and then set the equation equal to 0 and then factor from there. All right, so add 8x on both sides. So we're left with x squared plus 10x equals 24. We'll move 24 to the other side. We're left with x squared plus 10x minus 24 equals 0. So we're left with that nice monic, polynomial there. So we can go ahead and factor that. 24 in this case would be what? Positive 12, negative 2. So x plus 12, x minus 2 equals 0. So x equals negative 12, x equals 2. All right. So, those are all well and good. In the next one, you're going to see something that's interesting. Remember that we talked about vertical asymptotes, and the huge rule of math is that you can't divide by 0. It doesn't work. It never works. So, as you notice, we have a lot of variables in the denominator. So if we know the denominator is equal to 0, it's not going to work. So let's be aware of that as we start this next problem. So we have a fraction on both sides. We can just go ahead and cross multiply. So we're left with x squared minus x times 1, which is just itself 2 times x minus 1. Okay, beautiful. So we'll go ahead and distribute 2x minus 2. We'll bring all this to the other side. We'll subtract 2x. So we're left with x squared minus 3x equals negative 2. We'll add that to the side. X squared minus 3x plus 2 equals 0. We'll go ahead and factor x plus, x minus 2, x minus 1, right? Beautiful. So, all's well and good. We get our answer x equals 2, x equals 1. But wait, we have Houston, we have a problem. We notice that this 1, if we plug it in back to the equation, that's going to make the denominator 0. So that means this x equals 1 is not a real answer. This x equals 2, checks out. This is fine. So this is our answer. This is what we call an extraneous solution. They're your false friends. So just check them against the denominator, and if as long as the denominator is not equal 0, you're good to go. Let's check this next one. All right, so again, we have a lot of variables, but it's just cross multiplication. So we'll go ahead and do x plus 2 times x minus 3, keeping those binomials together with a parentheses, 2 times x minus 3. All right, so we have these two binomials there. So, go ahead and do a box just to, keep yourself honest. X and 2, x minus 3. So then you're left with x squared, 2x, negative 3x, and negative 6. Then that leaves us with x squared minus x minus 6 equals 2x minus 6. Right? Yes. Beautiful. Sorry. And so we'll go ahead and again and move all of this to the other side so that we can kind of factor it. So if I subtract 2x on both sides, let's see. Yep, I'm gonna get x squared minus 3x minus 6 equals negative 6. I'll add 6 on both sides. Oh, well, that's interesting. So I'm going to be left with x squared minus 3x equals 0. All right, so this is factorable, even though it's not a mnemonic, or you can just think of GCF, right? So I'll take the x out, and then I'm left with x minus 3 equals 0. Okay, so I know that my solutions are going to be x equals 0, x equals 3. We got to go ahead and double check them against the denominators of the original problem. So if we had a negative 2, it would not work. But looks like we don't have a negative 2. So both of these solutions should be good to go. All right, and that is solving rational functions. Hope you enjoyed and have a great week.